Hello and welcome to this section on mechanics and motion. Before we do any mechanics and motion, we must really take a look at vectors and try to develop an understanding of them so we can actually start doing some physics. We begin by just simply asking, what is a vector? Well, a vector is a quantity that has both direction and magnitude, and this is in contrast to a scalar, which only has magnitude. The best way to illustrate the difference between the two is if we consider speed and velocity. Speed is a scalar, and it only tells us about the magnitude. For example, we can say that we are traveling at 1 meter per second. Now, this is useful, but sometimes we need information about our direction as well. And velocity, we would be talking about traveling 1 meter per second at some speed in a given direction. So, for example, we could be saying that we are traveling at 1 meter per second in the eastbound direction, or northbound, or west, or northeast. It doesn't really matter, as long as we know the direction. And that's why we're talking about velocity. So we know the speed at which we are traveling and where we are going. And that is useful in life. I'll just zoom in on this. As you can see here, I've drawn some axes with a red arrow. And this red arrow is our vector. And I will call this vector V. And I will denote that this is a vector by drawing a little arrow above it. And this is just a notation that we use. To be complete, we'll just label our axes X and Y. Now, we've already talked about velocity and speed. Now we have our vector V, and this would be velocity. But we can also have speed, and this is the magnitude of the velocity, or the magnitude of the vector. And the magnitude of a vector is indicated by these vertical lines on either side of the symbol. But how do we express direction for a vector? We need to look at something else first, and that is the definition of a unit vector. A unit vector is just a vector that we define as lying along the axes. So we've got a green one to indicate the unit vector that lies along the x-axis. And we will call this I, and we indicate it's a unit vector with a little hat above it. And then we define another unit vector which lies along the y-axis. And we indicate that this is a unit vector with a little hat. And we call this unit vector j. Okay, so how do we express those vectors in terms of these unit vectors? Well, we can drop a line down from the tip of our vector down to the x-axis. And we know that this is some distance along the x-axis. And we will call this Vx, or the x component of the vector. Now, given that our unit vector I has a length of 1, we can express the x component, or how much we are moving along x in our vector, as Vx multiplied by I hat. And we can do the same to describe how far we are moving along the y direction. And this is Vy. And we express that by adding the y component and multiplying that by j hat. So this is saying that I have moved a number of units along x, and I have moved another number of units along y. So I've previously used the example of speed and velocity, and I said that speed is the magnitude of velocity. So in our vector, we've already written down that we have some magnitude here. So how do we find what this magnitude is? Well, if you look at this whole thing, this just looks like a triangle. And we know Pythagoras' theorem. We know that we have this hypotenuse, we have the opposite, and we have the adjacent. And we know that the hypotenuse squared is equal to the adjacent squared plus the opposite squared. And we know that the adjacent is equal to Vx. and that the opposite is equal to Vy. So from all of this, we can figure out that the magnitude of a vector is given by the square root of the x component squared plus the y component squared. Okay, let's clear this out. But let's turn this around. Let's say we know the magnitude of the vector, but we don't know the components. Well, as long as we know the angle between the x-axis and the vector, then we'll be fine, because then we can just use trigonometry, and it is pretty trivial to see that Vx is equal to the length of the hypotenuse, which is the magnitude of our vector, multiplied by the cosine of that angle, and then the y component of that vector is equal to the magnitude of the vector multiplied by the sine of that angle. Now this is interesting because here we are expressing our vector in terms of magnitude and angle, and actually this leads to polar coordinates, and we will go through that in a different video perhaps, but this is quite an interesting thing to stumble on. So that was the basic definition of what a vector is and what information you can gather from that. In the next section, we will start looking at some operations and what we can do with these vectors.